Hey, in this tutorial we're going to be looking at section 6.3 on the product rule. So we're saying if f of x equals g of x times h of x, then f dash of x equals g of x times h dash of x plus h of x times g dash of x. Okay, or if we're saying v equals uv, then dy dx equals u times dv dx plus v times du dx. I prefer to use this top one than this bottom one, but it doesn't matter too much which way you like to go. The other thing too is this one's good. You can't kind of stuff it up too much because we've got addition in between. Okay, which means if you did this part first and then that part, it wouldn't matter. The main thing is you're going the original of one function times the derivative of the other plus the original of the second times the derivative of the first. Okay, so we'll have a look at this worked example that we've got here. Okay, so we're saying that if f of x equals x cubed times sine of 3x, find f dash of x. Okay, so what I like to do is go, well, let's call g of x equaling x cubed and h of x equaling sine of 3x. Okay, then let's find out g dash of x. So that's 3x squared. H dash of x. Okay, we know that's going to be our constant in here is going to come out the front. It's going to be 3 cos of 3x. Okay, so now we've got all our parts that we need for our rule here, so we can just build it up. Okay, because we've got everything here. That's why I like this layout. Going our g of x, h of x, and our g dash and h dash. If you've got to do some work on these, because they're a bit more complicated, then you've got space to do that. Okay, but we'll go f dash of x, okay, equals g of x, which is x cubed, times h dash, which is 3 cos of 3x, plus h of x, which was our sine of 3x, times our g dash of x, which was 3x squared. Okay, so we're neating this up a little bit, so that we've got 3x cubed cos of 3x plus 3x squared sine of 3x. Okay, if you really want to, you could bring out 3x squared as a common factor and say that you're left with x cos of 3x plus sine of 3x if you want to. Okay, and we're done. So we'll move on to the next one. Okay, which is if f of x equals e to the 2x times x plus 1 squared, okay, then we want to find f dash of x and hence find the equation of the tangent at the point 0, 1. Okay, so we need to start off by actually finding our derivative. Okay, so again we're going to start off with saying, well, g of x is going to be e to the 2x, okay, and h of x is going to equal x plus 1 squared. Okay, so then our g dash of x, remember our constant just comes out the front, so that makes it 2e to the 2x. Okay, our h dash of x, okay, technically you should be using the chain rule here, but our quick way of the chain rule is bring our original power out the front, okay, times by the derivative of what's inside here. Well, the derivative of what's inside there is just 1. Okay, times x plus 1, reduce our power, just leaves it as to the power of 1. Okay, now we can bring everything together and say, well, f dash of x, okay, is again, well, we go g of x times h dash of x. So I'm actually going to write the other way around though and say 2x plus 1 e to the 2x. Okay, plus we go the other way now, okay, and we've got 2x plus 1 squared e to the 2x. Okay, so that's where we're at the moment. Okay, so if we want to, we could neaten that up a little bit as well and say that we've got what, 2x plus 1 e to the 2x, if you like, outside of 1 plus x plus 1, okay, because that's all we'd have left in there. okay, which would mean we'd have 2x plus 1 e to the 2x times x plus 2, and we can probably make that look a little neater and say we've got 2 e to the 2x times x plus 1 times x plus 2. Okay, and now we need to find the equation of the tangent at that point. So our equation of our tangent is y minus y1 equals m outside x minus x1. Okay, we know that x1 equals 0 and y1 equals 1. So x1 equals 0, y1 equals 1. Okay, we don't know m yet, okay, but m is our gradient at this corresponding x value. So what we need to do, okay, is we've got f dash of x now. We need to find f dash of 0. So that's going to be 2e to the 2 times 0 times 0 plus 1 times 0 plus 2. Okay, so that'll be e to the 0 is just 1, so that'll be 2 here times 1 times 2. Okay, so we're going to get a gradient of m, of 4m of 4. So m will equal 4. Okay, so now we've got everything we need to put in our tangent equation. So we can say, well, we've got y minus 1 equals 4 outside of x minus 0. So we've got y minus 1 equals 4x. So y equals 4x plus 1. Okay, and we've got our equation of our tangent. Okay, we've got one more worked example to do. So we've got f of x equals x squared e to the x. Find the coordinates where the derivative equals 0. Okay, so of course we're going to have to find the derivative first. So remember our f dash of x equals our g of x h dash of x plus h of x g dash of x. Okay, so we'll say g of x is going to equal x squared. H of x is going to equal e to the x. So g dash of x is going to equal 2x, and h dash of x is going to equal e to the x. Okay, so now we can bring everything together and say, well, f dash of x is going to be x squared times e to the x. So add e to the x plus 2x e to the x. Okay, which we could say is x e to the x outside of x plus 2. Okay, just taking out x e to the x as a common factor. Okay, and we're going to find where our gradient is equal to 0. Okay, so we can say then 0 equals x e to the x times x plus 2. Okay, so we're saying, well, e to the x is greater than 0 for all x. Okay, so we can ignore that one really, that's always going to be bigger. So then really our null factor law is x equals 0. Okay, and x plus 2 equals 0, so x equals minus 2. Okay, so we know that our gradient is going to equal 0 at 0 and at minus 2. Okay, is where we're going to be. Okay, and what they do is actually sub these back into the original one so we can get our coordinates of those points. Okay, so we'll say, well, f of 0 equals 0 squared times e to the 0. So that's going to be at 0. So we know we're going to get a point where the gradient is 0 at 0, 0. Okay, and when we put in negative 2, well, that's going to equal negative 2 squared times e to the negative 2. So we're going to equal 4e to the negative 2. Okay, you wouldn't actually try to simplify that because you'd end up with a horrible decimal, so we can just say our other coordinate is at minus 2 and 4e to the negative 2. Okay, and if you like, in the worked example, they show us a little graph. And our function goes like that. So there's a point here at minus 2, which is the turning point, and a point here at the origin, which is the turning point. Hence how we get our two solutions. So again, hopefully you've seen the product rule before, and this is a little bit more revision than anything new. But look, it's reasonably straightforward. If you follow a process that lays things out very well, like this one does, then the product rule becomes much, much simpler.